In the early 1800s, an estimated 30 million plains bison roamed the grasslands of North America. Over the next century, however, intense hunting by European colonizers caused the population to plummet, and by the 1890s, fewer than 300 bison were left. The loss of the bison had a devastating impact on the indigenous peoples of the plains and on the ecosystem in which bison played an essential role. Fortunately, the species was saved from complete extinction, and today, around 400,000 bison live in Canada and the US, although most are raised on farms for meat production. In order to restore some of their ecological benefits and advance conservation of the species, wild plains bison are now being reintroduced to parts of their former range, including, in 2018, to the backcountry of Banff National Park. To evaluate the success of this reintroduction, the bison and their influence on the environment will be monitored over the next few years. My research is helping to develop methods to measure the impact of the bison on vegetation communities in their new home in Banff. Specifically, I want to estimate the biomass, or weight, of grasses and shrubs that bison like to eat, and then measure changes in biomass over time due to bison eating them. However, while directly measuring biomass by weighing individual plants does give accurate results, it takes a lot of time and effort, which really isn't feasible across the vast areas where bison roam. With the ability to collect high-resolution images covering a large area, drones are emerging as powerful new tools for ecological research. I evaluated whether accurate estimates of vegetation biomass could be derived from drone images, which would provide a way to measure both individual plant and site-wide biomass from the same aerial survey. I flew a fixed-wing drone equipped with a digital camera to collect data at my study site in Banff just prior to the bison release. From the images collected, I used specialized software to construct a 3D model of the landscape from which I could estimate plant biomass. I then compared the drone-derived estimates of biomass to direct biomass measurements collected on the ground during the same time period. I found that from a single summertime drone survey, I could create 3D models that accurately predicted both individual plant and site-wide biomass, and from which I could easily detect changes in biomass due to bison browsing. These results indicate that drones are an effective way of measuring the amount of food available to bison across the landscape. My research also contributes a current estimate of biomass of vegetation within the bison reintroduction zone that can be used to monitor changes in biomass over time due to bison activities, supporting the management and conservation of this iconic North American herbivore as it returns home to Banff once more.